Now let's do exercise 2 from the linear function handout. The water level of a river has been rising for several days due to recent heavy storms. The water depth is given by the function f of x equals 0.15x plus 3.25, where x is hours of time and x equals 0 is midnight Sunday. And f of x is the depth in meters at a measuring station. So the input variable is hours of time. The output variable is meters that measure the depth of the water. And so here's our formula. I have recopied down below. In part A, we want to know what is the water depth at noon on Monday. Now, it's never my intention to make the language so tricky. Like, this isn't supposed to be tricky, figuring out what value of x this is. So it's my job to make the language clear, and if it's not, it's my fault. X equals 0 is midnight Sunday, so x equals 1 is 1 a.m. Monday. I could have even added that to this statement. X equals 2 is 2 a.m. So at noon Monday, that's going to correspond to x equals 12. And again, that's not supposed to be the point of the problem to figure that out. That's meant to be pretty clear for you. So we want f of 12. We want to plug that into the function. Is 0.15 times 12 plus 3.25. And I went ahead and figured this out ahead of time. This turns out to be 5.05. Now write the units on this because we got time involved, we got meters of depth. You got to say what this number stands for, and it's meters. And so that's the depth at noon Monday. Our answer part A. Okay. Part B is if the flood stage is 6.7 meters, when will the river reach flood stage? So in part B, we want to find t for which I would say f of t is equal to 6.7 meters. In other words, I want to take that expression for the function, not t. We want to find x. We're using x here, sorry. Find x for which f of x is 6.7 meters. So I'm going to take my f of x expression for the function, which is 0.15x plus 3.25. And I want to set the expression equal to 6.7. 6.7 equals 0.15x plus 3.25 and solve for x. So for this part, I have a little bit of algebra that I gotta solve, right? And let's see, I'm gonna subtract 3.25 from both sides. And 6.7 minus 3.25 is, I get 3.45 is 0.15x, and then I get to divide both sides by 0.15. And 3.45 divided by 0.15 is 23. I get 23 exactly is x. So now that's x equals 23 hours go by. But it's kind of nice if you could express this in terms of, Monday, 23 hours into Monday. Can we all agree that this would be 11 p.m. Monday night? Because 24 would be one full 24-hour period would take us to midnight Monday. So we're 1 hour before midnight Monday. Okay, part C on our problem is how many hours will it take for the reservoir, I'm sorry, at what rate is the river level rising? Sorry, lined up with the wrong one. So we want 2C. Rate of river level rising. And there's really no calculation here. I hope you just recognize from our formula for this function that it's really the slope of this linear function, the m value, 0.15, that we can just pluck off. So the river is rising at the rate, it's actually a constant rate, of 0.15 meters per hour. A rate will always have units that are something per something else, and it's always going to be output units per input units. So output units in meters per input units of hours. So it's just the slope, okay, the slope of the linear function. Okay, so I guess I'm just gonna stop number 2, and we'll do a separate video for exercise 3.